So when it's odd, I'm just going to cross right through. When it's even, I'm just going to touch and go. All right, so let's try graphing this. So I'm seeing this. This is an even that is going to tell us we need to bounce. Same thing here. This is telling us we're going to have a bounce there. All right, so that's x equals 0. X minus 2 is going to give us 2. And x plus 1 is going to give us negative 1. So we can get a lot of information without doing a whole lot of work. 0, 2, negative 1. We already know a little bit that's going on here. So if we were, I know it's not multiplied out, but we can get our end behavior. This is x to the 4th. This is x to the 3rd times some other stuff times this is x squared times some other stuff. So when we go to multiply this all together, these three guys are going to get multiplied together. That's going to give me x to the, let's see, 4, 7, 8, 9, x to the 9th power, and a whole bunch of other things. They all have leading coefficients of 1, so when I multiply them together, I'm still getting positive 1 here. 9 is an odd number, so they're going to do opposite ends. They're going to do two different things. The 1 is even, so it's down on the left, up on the right. So I already kind of have a pattern going on here. I know that we have a bounce at 0. So that means if I'm starting, we are going to either go like this or go like this, depending on what's, the plan here, really. I also know at 2, I am going to cross through it. And I know at negative 1, I'm going to bounce. Okay. So if I'm starting down at negative 1, I should expect to bounce here. I'm going to go somewhere else because I have to bounce again when I get to 0. And then I'm going to cross through when I get to 2 so that I can end up on the right. So I haven't had to plug anything in yet to kind of get an idea of what's going on. And that's really helpful. All right. So maybe let's just pick something between these zeros, and that'll probably give me enough information to go on here. So I could pick, I don't know, how about negative a half? So if I put in negative a half into my table, I'm going to get almost negative 4, negative 3.9-ish. So somewhere down here. And then if I plug in, I don't know, how about just 1? That might be easy enough. 1's going to give me negative 4. So just right around there. So it'll do something like this. Okay. So without having to plug in a lot of information, I got a pretty good sketch of my graph. And I can always go to Desmos to double check what it looks like, but we can do this without a calculator, and that's the beauty of it. One more tool for our toolbox is local extrema, or maxes and mins, or maxima, which is just plural, and minima. We can get local maxes and mins. They show up all over the place. They're like our hills and our valleys, and we've talked about them before. One thing that's important to note is that we can tell, kind of as a little trick, how many, well, not how many exactly, but what is the most number that we should expect to see. So if I have something that is a 5th degree, I should see no more than 5 minus 1 extrema, or local extrema, I guess I should say. So really, there's no more than 4 maxes and mins in total. That doesn't mean there has to be 4. There might only be 1. There might be none at all. Well, I guess there would have to be 1, but there might be only 1. But there can't be any more than 4. That is the most that I'm allowed to have, and that's all based on this degree. So 1 less than the degree. So let's determine how many local extrema each polynomial is going to have. So first of all, when I take a look at this, there should be no more than 4 minus 1. So no more than 3. So right away, I have a pretty good idea of what's going on here. No more than 3 of them. I should not expect to see any more than this. Now I can go through sketching this, or I can take a look at what the graph of this is going to look like. But I could do what I was doing before and try to find some zeros, but it's kind of hard when it's a long polynomial that I can't factor. So for now, let's take a look at our Desmos real quick and see what this graph looks like. So we have y is equal to, that's x to the fourth power, x to the fourth. We've got plus x to the third. Minus 16x squared. And then we have minus 4x plus 48. All right, so we really need to kind of fix this zoom a little bit. But as we take a look, we see we've got one down at the bottom, one extreme at the bottom, one at the top, and another low. So that's 1, 2, 3 extrema, and that's the most that we are allowed to have here. And again, that was just because we had that quick sketch, but it looked something like this. 1, 2, 3. And we can do the same for all of these. If we check, when we go to take a look at this quick sketch, it's going to look something like this. And again, you can just check with the calculator what these graphs look like. There's going to be 4, which we knew there could be no more than 4. But let's see, if we take a look at the graph, it's going to look something like this. We are only going to have 1 here, and that's okay. We don't need to have more than 1. Lastly, we want to compare what do these graphs look like. So we have x to the third minus cx squared. And what we're doing is changing out c. So we want y is equal to x to the third minus, first we'll start with 0, x squared. Then we have y equals x to the third minus 1x squared. We want y equals x to the third minus 2x squared and, squared. And then lastly, we want y is equal to x to the third minus 3x squared. What we're going to just do is kind of compare what's going on here. So how does changing that c affect the graph? Well, what we can see is the end behavior, especially when we're zoomed out, looks very, very similar. On the left, it's going down. On the right, it's going up. It's almost like an overlap going on. So I really don't see the change until I zoom in. And as I zoom in here, what I'm seeing is the change in the kind of dip. Can I just do sort of? That's a little better. So if I look at red, which is where we only have x to the third power because that 0 term drops out, I don't have any dip down in the right, but that blue starts to dip a little bit low right about here. That local max gets real low, and it gets lower and lower as we go. But otherwise, these graphs look incredibly similar.